Hi, welcome to the Microsoft Partner Showcase. In this series, we're hosting technical discussions with partners on the software industry and on their solutions. In this episode, we discuss data meshes and modern analytics with Starburst, a multi-cloud analytics platform whose offering greatly simplifies the deployment and management of Trino clusters while also extending its functionality. Shaun Van Staden, the Director of Cloud Architecture at Starburst, helps explain these concepts and will also demo how Starburst works and delivers on querying data where it lives. We've indexed all of the chapters so you can jump to any point in the conversation or straight to the demo. Let's begin.
Hi, everybody. How you doing? I'm Brian Hitney, a cloud solution architect with Microsoft, focused on data and analytics. Welcome to our Microsoft Partner Showcase. I'm joined today with Chris Mitchell, a colleague of mine. Chris, would you like to introduce yourself?
Hi, everyone. I'm Chris Mitchell. I'm also a cloud solution architect with Microsoft, focusing on analytical solutions. And today we're joined by Shaun from Starburst, and Shaun's going to talk to us about their offering. One of the things that we find in the analytics space today is that data mesh is a very popular topic. And while there are a number of ways to approach that architecture, we think Starburst has a pretty unique offering that is worth highlighting. Shaun, could you tell us a little bit about Starburst's position in the market?
Yeah, absolutely. So thanks, guys, firstly. And so Starburst takes a pretty unique view on this one, in the sense that what we are as an analytics engine is we very much focus on the query side of the engine. So data, we don't have data that's inherently stored within Starburst. In fact, what we enable you to do is to connect to your data in your cloud environments. And then even if you've got data sitting, say, outside of that cloud environment, and connect it all together and give you the ability to access that data directly in cloud, as if it's all singly attached. And this is really the whole concept of decentralized access to data. This is why Starburst exists. It's built on some technology that's been around for about 10 years now. And I'll get into it in a bit more detail here in a minute.
Chris and I recently ran a LakeHouse workshop that was about helping architects and data engineers understand the LakeHouse pattern a bit. Would you say that data lakes and that LakeHouse pattern is really central to Starburst and data? Is that the largest type of data that you see in your implementations?
Yeah, absolutely. I mean, the fact is that that's natively where the engine, the whole purpose of why the engine was built was to solve that, firstly, data lake problem, and then sort of in more recent times, migrating, or at least moving to the LakeHouse motion. And today, in terms of like Starburst customer base, pretty much every single one of our customers has a LakeHouse or a data lake as a central part of their data strategy. So they obviously got data in other places as well, but that's definitely the core center of their data gravity. And you'll see, why that is why Starburst is able to help with that analytics, because we have an engine that can natively read in a very performant way. And then our view is that why the LakeHouse then becomes so important is it's all about scale, right? Because underneath the hood, we're talking about object storage, and storage systems like ADLS can handle thousands of users simultaneously accessing data, which means that we can scale up to pretty massive scale and have thousands of users using our platform with no discernible impact on performance as users are running whatever analytics they're trying to run on top of that.
One of the things I hear a lot from customers is that while the data lake is a valuable way to collect and centralize your data, a lot of times that creates friction in implementation, simply because it increases latency, or the customer might be embarking on what I would call a domain-driven data architecture, where you've got different business domain owners. I'm curious what your position is on that and how you guys fit in that space.
So yeah, we've taken firstly, yeah, that's so true. In fact, if you were to look at just the core technology that we provide, it's not going to provide you that capability. So the Trino engine is what we built on top of. It's an open source engine. That's the product that came out of Facebook many years ago. That's now sort of open source, and then obviously we're the commercial entity on top of that. But where I'm going with this is that engine by itself doesn't give you the ability to manage entities like domains. And that's where we start to layer on enterprise capability, where now you can start logically defining domains within your system and have that centralized governance, which, by the way, doesn't necessarily have to be managed within Starburst. In fact, Starburst doesn't contain a governance product. We're primarily on the query side of things, but we do allow you to layer in the concept of domains. And this is really when, and we'll start to talk about data mesh in a little while, but this is really one of the foundational blocks of building out a data mesh strategy, is by starting with these domains. And then, with Starburst being able to operate within these domains, we can start to have multiple different business units operating within the same Starburst environment. But then with the layer on top of that, the security and controls that you would expect when you're trying to restrict access to different parts of your system according to who's trying to access it.
Sure. Okay. So would you then characterize what you're offering as like a virtual data warehousing solution, or is that too much of a trivialization?
Yeah, it's a little. I mean, it's a little bit of that. I mean, we can. I mean, obviously, we are not a data warehouse or anything like that, but we definitely are. I mean, the terms that I hear a lot of is like data fabric, data mesh, data virtualization to some degree, and we all kind of fit into that. In fact, when you look at us, this is why we get compared to a lot of like adjacent products, and like sometimes people will be comparing us to like a Snowflake, and other times to a Denodo. Because we do kind of overlap depending on what the customer is trying to use, how the customer is trying to use us. And I think that's inherently where our strength is because we have that flexibility that we can look and operate like a data warehouse in certain circumstances. And on the other hand, we can behave like a data virtualization layer.
Right.
So you've got that sort of flexibility depending on what you want to do.
Well, and I think that's one of the key reasons why we wanted to talk to you guys is that, one of the objections I hear often in, alternative approaches is it requires you to move data to that central location in order to provide your analytical store. And a lot of times that can be a challenge either from, like I said earlier, latency reasons or from, span of control reasons. Like we don't want to, move the data outside of our system because of, governance or security reasons, so, except at query time. So.
Yeah, no, absolutely. And then just on that point there, it's quite interesting because we talk a lot about query federation and querying data where it lives. And at the same time, I'm talking about querying out of a data lake. And quite honestly, we operate completely within that spectrum because I'll go back to that word optionality, because the customer now has the flexibility to start doing discovery with data in multiple locations. And then ultimately, they might choose to centralize that data at some point down the road. And generally what drives that centralization, if you will, is needs around either security or performance reasons. But I like to think of it as we can operate between either extreme and anywhere obviously in between. And that's really where the flexibility comes into play.
You mentioned being built on top of Trino. If you're working with, say, someone who's used to classic data warehouse implementation and you're in an elevator, they don't know what a data mesh is, but they understand data lakes and data architectural patterns. How do you describe a data mesh to them?
Yeah, data mesh is a very academic subject. That's the thing. And we have a saying here at Starburst is like, we don't really sell data mesh. We sell concepts around it. I mean, a customer might end up implementing a data mesh, but like how I describe data mesh to somebody who's never heard of it, it's a social as well as a technological framework, right? So it's bringing together business and technology in a way that makes it firstly easier for the business to access data without necessarily being overly reliant on central IT as being either a bottleneck or a hub where all of the requests need to get filtered through. Because the whole objective of data mesh with the decentralized approach is it's less about bringing data together and having that centralized governance. It's all about your domain ownership. So every every user who's coming into the system has access to underlying systems, and there are, if you will, individual governances that might be involved, right? So, or separate governances that might be involved. And the data mesh, that sort of paradigm or that concept actually makes it more efficient for business users to then get access to the data that they're looking for. Because as you know, and this is really where the whole decentralized piece comes into play, as you know, when you start looking at bringing data together, that's typically when things start to slow down. And businesses' needs around data is typically, I mean, their requirements are changing faster than IT's ability to deliver data to them in a centralized place. That's really why the whole concept of data mesh has pretty much come about. And it's not really a new thing. I mean, it's probably been around for a long time, but this is the first time that it's been kind of formulated into a framework this way.
Yeah. Well, and I would imagine too that, well, I've seen this a lot actually, in that schema drift of upstream systems can have, really terrible, upstream impacts from, an ETL and any sort of data movement, data manipulation layer that is trying to prepare data for that the final destination. So, data mesh is really, kind of really useful at alleviating some of those problems.
Yeah, absolutely.
So, Shaun, why don't you tell us a little bit about Starburst as an engine and some of the core foundational pillars of Starburst?
Yeah, absolutely. No, thanks. So let's go ahead and do that. So we like to obviously refer to Starburst as the analytics engine for all your data, because we're connecting people to their data. And the best way to look at this, there we go, is to firstly visualize, how you should be picturing Starburst when you think of us. So we very much think of ourselves as that query engine. We are going to be part of an overall solution. I mean, even like we were just discussing data mesh a few moments ago. We are not an overall data mesh solution. We know we are part of what could become a data mesh implementation. Now, there are key pieces that we fulfill, mostly around being a query engine, being able to connect to decentralized data in a very, very efficient way. But we've also sort of enhanced the platform as well and sort of introduced concepts around, so these are core concepts of data mesh, specifically the concept of a logical data domain, and then the concept of a data product, which is pretty central and foundational to data mesh. But that's capability that's built into our platform. But I'll go back to something that I said in the beginning. We don't have data, we don't store data, we need to connect to data, right? So we have a number of different ways of connecting to data inside and outside of cloud environments. We can support connecting to data lake, so object storage types systems, obviously relational databases, NoSQL databases. We can do real-time analytics streams, and then obviously applications is a fairly newer one for us. That's where the data needs to reside. What we're simply doing is abstracting that, and how users interact with that is just through straightforward SQL. So the users who are operating Starburst, they could be business users, they could be data scientists, they could be data engineers. And what I mean by that is that I could be somebody who's building a Power BI report. I don't necessarily know what SQL is, but I know how to build a Power BI dashboard. I could have my Power BI application pointed directly at Starburst, and I could be, building my dashboard, and that gets translated into SQL, and Starburst is taking care of the delivery of the data to me. Conversely, on the other side, I mean, I could be a data engineer building a pipeline in dbt or something like that, right? This is a sort of a fairly, I wouldn't say new, but it's definitely a growing use case for us, and I'll talk about that as well. But the whole concept of using an engine like Starburst to do ETL, which is maybe a little bit counterintuitive based on everything we've just been talking about, the whole concept of decentralized access to data. But the reality is that data still needs to be moved, and we're not about getting rid of ETL. It's more about optimizing when you need to run ETL. And so we may or may not be part of that process as well. But point here is that I want to kind of point out is that, we do have users who use us in that capacity. So from your extremes, from, business user building a dashboard, maybe some SQL Power users running SQL, to data engineers and data scientists who are pulling data out of the system for their purposes. Overall point being is that they're typically interfacing with our platform using their existing tools of choice. And then we become that invisible layer in between. And then inside that invisible layer, you've got your data authorization controls and all those other capabilities that I mentioned. But that's how we like to look at ourselves. Definitely part of a whole, not the full solution. So let's talk a little bit about how we see the world, right? And this is where we start. I mean, when I talk to partners, they always ask me about, business use cases, and it's like, well, technically we can support hundreds of different business use cases, but the way to distill this down is to look at what Starburst is good at from a technical perspective, right? And depending on where their customer is in their journey, this is where we typically see how they move, right? So it's about either, they might be starting with a data centralization policy where they've got they're doing ETL processing where they've got a lakehouse or a data lake. Maybe there's a little bit of let's reach out and connect to data outside of the system. But that's where a lot of customers would start from. But as they kind of evolve along this journey, you're going to start to see they're going to leverage query federation more. And that's really about connecting to multiple different systems. I mean, a good example inside Azure would be, what if a customer had data that was in Synapse, but then also had data that was in ADLS, and then was also trying to leverage data that they might have in like a SQL Server database or Cosmos DB or whatever that might be. Your options in the past would be, I've got to move it all into one place before I can get value. Well, with the whole concept of query federation, I don't need to do that. I can now do discovery by connecting to all those systems in the way that I described previously, just through straightforward SQL. No translation necessary. I don't need to understand how to query individually those underlying systems. I just have one way of querying it, and then Starburst will take care of that translation for me. So that query federation is obviously is quite a strong use case for us, and a lot of customers, that's what appeals the most when they see what we do. LakeHouse is our bread and butter, but query federation is like, this is easy for us, right? This is how I can start. So, and where I'm going with that one is that pretty much every single one of our customers is querying multiple sources of data at once. They might have a centralized approach, but at the end of the day, they still have a need to query data across multiple systems, because every time they do that and then they're satisfied with that result in terms of latency, performance, security, etc., like that, that's one less ETL process that they need to write.
Right. Yeah.
Mm-hmm. I won't really touch too much on being an embedded analytics engine. This is kind of like a side use case for us, but we do have, and this is maybe outside of cloud, but we do have some partners who actually use our engine. As I described before, the fact that we're very invisible, they just build their own applications on top of us, and then we just become part of their core product. But so that's like a side case for us. But then as we kind of move through this evolution, if you will, and this is where we start to get to the data mesh concept. And customers start, like I said, in the beginning with LakeHouse and query federation. Eventually, they start building data products on our platform and start implementing towards a data mesh. I mean, there are other pieces that you have to bring into bear to kind of fit the definition, if you will, of what a data mesh should be. But we definitely fulfill the capabilities of being a query engine, and then obviously having the capability to create data products for the organization.
Okay.
Mm-hmm.
Yeah, that really helps, kind of bring focus on what's unique about your implementation, for sure.
Yeah. Absolutely. Yeah, and so I mean, with that, I mean the next thing I can do is just show you a little bit about the product. This is what we call our Starburst Enterprise platform. So this particular one is running on an AKS cluster. So our typical deployment mechanism is through managed Kubernetes. This one's running on AKS. As I said before, I mean it just so happens, I think we're using LDAP for authentication, but we do support Azure Active Directory as an identity as well. But in terms of the kind of the core product, most end users will not really be looking at this. I would say they'll be using their products as I mentioned before. But this is still a very useful place for admins to come in, because firstly, it's giving you that snapshot of what your cluster looks like. So because we leverage AKS, we leverage the elasticity that Kubernetes inherently provides. So I could have a Kubernetes cluster that my Starburst cluster is running on that could be scaling out from any, from as little as one node to, hundreds of nodes, depending on what my needs are. I can see a snapshot of all of that here. I can see what queries are currently running, what queries have been run, who's been using the platform. I have all of that information to hand. So that's what we call our insights. So you can see, historical queries. I can look at how the cluster's been performing over time, and overall like usage metrics as well. This is pretty good if a customer is trying to estimate what their cost is going to be. We have this little piece in here where they can go work that out. But all of this is to hand, right? So as an admin, I can come in here and I can look at this. All of my end users could also technically log in if they've got access to the platform, even though they might be using, Power BI, DBT, whatever it is. They can still come here. They can still log in if they wanted to, and then they can go straight to a query editor and they can start running queries. Now, this is quite powerful in itself, because I can use this to both, query and explore data, as well as, do things like run ETL jobs. So this is one thing I didn't really touch upon, but it is a use case for us, and it's one that actually came out of our customers, because we always, I'll go back to something in the beginning that I said. We grew out of the fact that we can query a lake, and also we can query across different data sources, and that's where a lot of customers start. But eventually customers realize, well, if I can write a select statement like this, and I'll just quickly run this while we're talking. If I can run a select statement like this, where I'm pulling in data from, Hive, from Delta Lake, from Oracle on an AWS, I'm pulling it down to my Azure environment, a Postgres database that's running in my Azure environment. I can do all of this like this and create this set like this. Well, they figured out, well, if I can do that, can't I just turn that into a create table or an insert or something like that and actually move the data? And yes, they can. So they started doing that. So we ended up responding to that by building capability into the platform. That means that you can now use the engine more like, you can leverage the engine as an ETL engine. What I mean by that is, ETL jobs typically can take a lot longer than just an ad hoc query like I just ran here. I could spend hours as reads data and then has to copy it to a location. And then you want to protect that, right? You don't want a job failing, 2.5 hours into a 3-hour job, because you're going to have to start it again. So we built this concept. Well, we created this feature called fault tolerant execution. And then simply put, what that means is that now, as this distributed query engine runs and jobs get split up between different workers, those little splits are essentially protected, right? So as a job finishes, it's going to checkpoint that and save that off, so that if any point along the line something fails, like you lose a node, or there's a whatever other type of failure, there can be an instant recovery from that point in time, rather than having to restart the whole job again. So that's really what fault-tolerant execution gives the ability to do. So now, not only can I use it as an analytics engine, like I've shown you here, but I can also now use it as an ETL engine with that fault-tolerant capability. And then the only other thing that I'll call out here, and this is kind of an extreme example, but if you look on the Cluster Explorer here, we connect to. This is just for example purposes, but obviously we've got a lot of connections here. This is really just to highlight the variety of connections that we can connect into. And then also we have this very special capability where you'll notice that some of these say AWS underscore and GCP underscore. Well, we have this very, very special connector called Stargate. And what Stargate allows me to do is connect this Starburst cluster to a Starburst cluster that's running somewhere else. Could be across region. It could be in another cloud, because I've got a center of data gravity there. It could be on-prem even, if I wanted to do. I can connect directly to those sources, but there's a good reason why I might want to use Stargate and do it this way. And that's primarily because, maybe there's data that can't be pulled out the region and be processed because of data residency requirements. Good example. Imagine if I was, had a multinational data footprint, and I had data in Europe and I got data in North America, and I'm running reports in North America, and I want to do some analysis on the data in Europe. Well, I can't pull it out and run the compute here. So what I could choose to do is use Stargate, and let's say the data is in Azure in both locations. I can have a Starburst cluster running in my EU region, and I can have that processing happen there, if you will. And then the data that is allowed to leave will then be allowed to leave. In other words, the aggregate level data. So Stargate can be pretty powerful in enabling you to do that, and that's primarily why we have it for that capability. But there you go. I mean, that's really what I wanted to highlight here is the capability of the platform.
One of the scenarios I just thought about while you were doing your demo was looking at the fact that this effectively can be an abstraction layer on top of your other potentially other analytical stores or other databases. Have you ever run into any scenarios where you've had customers that have wanted to use this so that it would facilitate a migration from one platform to another? Because I can imagine by using this as an abstraction layer over the data, when you migrate the data, you change its connections, and the applications that are consuming your analytics is are just ignorant of that change.
Pretty much, yeah. So a lot of our early success. So the first customers who bought us for that reason, right? People become that abstraction while they were doing a data migration. So there's a bunch of customers that I can rattle off here, but essentially a lot of it was, how do I get off of legacy on-prem data warehouse into the cloud very fast?
Yeah, and that's exactly the scenario I was thinking of, because there's a lot of people that are like, hey, we've got an old school data warehouse, it's janky, we need to get rid of it, and we want to improve our approach while we're going to the cloud. So we want to incorporate the data lake and larger data and so forth. Yeah,
exactly. In fact, that's a good segue into I guess our data products here. I could probably highlight that. Yeah. So firstly, if I'm a user and I'm coming in here, I've got all of these connections, right? Maybe it won't be as extreme as this, but as a business user, I might not have context of these things, and I might not care. It's like, do I really care if I'm querying data that's currently sitting in my warehouse on-prem, and then in 6 months from now, it's going to be migrated off and sitting in cloud? I mean, I don't need to know that. I just need some type of an abstraction, and to your point there, like a view. So this is where something like a data product can come into play. So now I can create a data product, which effectively is either, in the case of what we just describing, could start out as a view, could also be a materialized view, but it's a simple definition that can get redefined as that data moves around. So today, and I'm looking at this now, and this is I've got a definition of a view here. So let me see if I can actually see it. More or less, I can see the column. So there's a query that's underneath here. That's where this view is being derived. In this example here, maybe this view is pointing at some data that's on Teradata on-prem, and maybe it's also pointing to some stuff in cloud. The end user just sees that view. 6 months from now, my data is the data that I'm needing out of that on-prem warehouse might now be in ADLS or in Synapse or something like that, and I can just repoint the view to that new source. End user doesn't change. They're not impacted at all because they still keep querying that same view. So it's completely invisible to them.
Yeah, I can imagine that could be super powerful in a situation where you're trying to do a cutover from an old system to a new system, and you're able to fail back fast in case something goes wrong too. So yeah.
Absolutely, that's a great point as well. Yeah.
So obviously, the setting up data sources and data products here is that largely done via SQL syntax, or is the management console that does that? Could you talk a little bit about that?
Yeah, I mean, So firstly, data products are currently built by SQL today. So you need to have some understanding, and the way we look at it is that if we think about how our business might operate using data products, is they're going to have to have somebody who maybe in the past was building ETL pipelines. Maybe that they'd still have somebody like that working within their domain who would be helping them build out some of these products. So we'd obviously need to understand, firstly, down to this level, where the source data is, how to join it, if there are reasons to materialize or just have logical views on top of that data. I mean, they'll have all of that understanding and context. They will be building out these data products, and there could be several of those users out there doing exactly the same thing, obviously operating within one or more data domains, and then publishing these data products like this, and then those data products are then searchable by the business users who are accessing the platform. So now I can obviously have users who are those few more steps removed from the technical aspect, coming into something like this or looking at it through some other interface, and then seeing, oh yes, here's the data I'm interested in, right? So here are my credit card platinum customers, or here's my claims information, or here's my customer segmentation. Depending on what my business use case is that I'm trying to build reports for, I now have a nice simple way where I can go and find that, search for it, find it, and then just leverage it in my reporting.
Great. Well, that's super helpful. So I'm curious, if there's if somebody wants to dig in and learn more about your platform, what do you guys offer in the way of resources, learnings, trainings, and so forth?
Yeah, so there's a couple of ways to do this. So we have an Orbit. Hang on. Let me rephrase. We have an enablement platform for our partners, which we call Orbit. That's typically where most partners go to. Now it is quite in depth. There's a lot of training materials involved there. Also, partners at least have access to licenses for our software, and then access to our Harbor repository, so they can do their own installations if they want. That's all based around our Starburst Enterprise platform. So if you want to get your hands dirty, you want to install the platform yourself on your own AKS cluster, we've got instructions in here that tells you how to do that. So a couple of jump starts. There's a lot of learning material around concepts around what Starburst is all about. All of that, like I said, it's all baked into here. I won't go through it because it's quite involved. That's your one option. Your other option, obviously, is if I just go to starburst.io. Oops, if I can spell starburst.io. If you just want a quick look at the platform, I've been talking a lot about Starburst Enterprise, but if you want a quick look, there's always Galaxy. Galaxy is our SaaS version of the software. So that's fully managed. All you need to do is sign up for an account. I think I do have one available here that I can show. Galaxy Live. Okay. I say this is if you just wanted to get your hands dirty in it, just kind of get a play around. You might notice it looks very similar, the login screen, to what we saw on Enterprise there. It is slightly different in the sense that now you've got the cluster. In the past, in Starburst Enterprise, I was operating on the cluster. Within Galaxy, I'm sitting in a control layer one step higher, and then I can see those clusters over here. So it's just one step above it, if you will. We are obviously running these clusters for you, so we've simplified that piece there. So you do not have to do the installation yourself if you don't want to go through that. I can just simply come in here. You will notice that it is multi-cloud. So I can have clusters running in Azure, Google, or AWS here, depending where my data is. But if you've got data in Azure, which most Microsoft folks will somewhere, I can point to that data. Only restriction that I'll have here, last piece to call out on Galaxy, is that Galaxy, it's been around about just over a year now. But you'll notice that the catalogs, the connectivity isn't as expansive. We do have the important ones, and they're mostly cloud-based. So you're not going to find your on-prem connections here. So if you are specifically looking for certain on-prem connections, Teradata, Exadata, Netezza, maybe some of the other sort of more interesting niche ones, definitely use SEP for that. But if you are just wanting to connect in your Azure ecosystem to Synapse, to Azure Data Lake Storage, SQL Server, you're going to do just fine with using Galaxy. And like I said, it's the fastest way to get it. It takes like a minute to get your account set up, and you can attach your data, and you can be querying data within 5 minutes or so.
Perfect.
Yeah, that's great. I recently noticed that you just completed, and when I say recently, this is late February 2023, your Datanova 2023 conference, and it looks like you're planning for Datanova 2024. Any highlights from 2023 that you can mention, or things that you're looking for in 2024?
Yeah, so there's a few things. It's funny when you say that, because every time we finish the Datanova conference, they start planning for the next one almost immediately. But some of the ones that sort of came out, and the two key ones that I'm particularly interested in, the first one is this. We're calling it warp speed. It came out of a company that we acquired last year, which accelerates access to object storage. And what I really mean by that is that when users are querying data that's in ADLS, you're never really going to approach the speeds of a database, a relational database, or even a data warehouse, because it's not highly optimized. But when you start enabling things like warp speed, this is now an intelligent agent that sort of runs autonomously and does smart indexing of your object storage data in order that it can actually start speeding it up. And when you start querying and having sort of querying non-partition columns in your where clause, you can start to realize sort of massive performance improvements just by having this feature switched on. And when I say massive, I mean I've seen anything from 7 to 10x improvements on that. So on our internal environment, when we were running tests, yeah, a query that say was taking like a minute and 20 seconds to query data out of object store would take less than 10 seconds with the switched on. I mean that's going to be huge, because what this basically means is now you're getting to a point where you can now leverage your data lake, your LakeHouse, more like a database or a data warehouse, right? Especially LakeHouse, because iceberg format or Delta Lake format, that supports CRUD operations, so I can do inserts, updates, and deletes on that data, at the speed approaching what a warehouse or a database is able to do. So that's a super interesting one. I'm definitely interested and excited about that feature. The other one, which also is, it kind of came out of nowhere, to be honest. I didn't know about this until the week before Datanova, but we've added capability to the platform so that we can natively support Python. Okay. So this ties in a little bit to the ETL processing that I mentioned, right? Because a lot of data engineering, especially if I look at products like DBT, they're building ETL pipelines in Python. Data scientists are using Python. Everybody's using Python in some way, shape, or form. And so by having this native connector, you can now submit. Well, it's not live yet. It was just announced. So I'm waiting for this to come out. But so you're not just being able to submit SQL. I can now start submitting Python to the Starburst engine. And have that execute in a completely different way. That's pretty. I mean, if you understand how things were working in the past with Starburst, that's pretty groundbreaking. Because in the past you would have had to write SQL within your Python to extract data. Now you don't have to do that anymore. You can literally just write native Python to pull data.
Push the Python down to the cluster instead of
Exactly. So those I think are two key features. They're going to be pretty significant for us this year, I would imagine.
Yeah, I would say that the popularity of Python these days, because you especially see it a lot in like in Spark and data engineering, like you said, they bring other technologies. So yeah, I can imagine that would be an extremely useful feature.
We really appreciate you taking the time. Enjoyed the conversation, enjoyed the demo, and the direction of where the products are going. So that's really exciting.
I really appreciate it. I think you got a really unique way of approaching this, and I'm excited to see it in Azure, and hope to see more of it.
Yeah, thanks very much, Shaun, and thanks, Chris. Thank you for everybody who tuned in. Hope you got something out of it, and thanks for watching the Microsoft Partner Showcase. Take care, everybody.